Now let's pick from where we left last time, and we are continuing with the discussion on investment appraisal techniques. We said that we have investment appraisal techniques classified into two broad categories. That is the non-discounted cash flow techniques, whereby we have the payback period and accounting rate of return. Now, payback period means the time taken by a project to generate cash flow, which is equal to the initial capital outlay. That's what we mean by payback period. How long it takes for the project to generate cash flow which equals to the initial capital outlay. If, for example, you purchase a machine for shillings 1,000, and this project is generating 100 shillings per year, then after 10 years, it will have generated the 1,000 shillings. So in that case, 10 years becomes the payback period. That's payback period. The other that we discussed was the accounting rate of return. And basically, those are the two types of, or the two categories of the non-discounted cash flow techniques. Now we move next to the other classification, and that is discounted cash flow techniques, whereby we will be discussing the net present value. Then we have the internal rate of return, then profitability index, and discounted payback period. In this lesson today, we focus on the net present value. Now, with the net present value, as we have said, is one of the discounted cash flow techniques. We need first to know how to calculate the net present value, and then after that, how to advise or how to make decisions based on the net present value calculated. Now, what we are supposed to understand is that with the net present value, you'll be given some cash flows, future cash flows. Now, with these future cash flows, what you do is that you calculate the present value of those cash flows. Then once you get the present values of those cash flows, you deduct the initial capital outlay. So once you deduct the initial capital outlay, what you get is the net present value. If your net present value is a negative, then you reject the project. If the net present value is a positive, then you accept the project. However, if the net present value is a 0, then you should be indifferent. That is, the project can either be accepted or rejected. Now, once you have understood that, the other important thing for us to note is that if the net present value is negative, if you get a negative, the reason as to why we should reject the project is that the meaning of negative net present value is that such an investment decision or such a project is likely to reduce the value of the firm or the value of the business. If you acquire a machine and then you calculate your net present value and you get your net present value as a negative, it implies that the acquisition of that particular machine will lower the value of the firm, and therefore the reason behind the fact that whenever you get a negative net present value project, that particular project or asset acquisition should be rejected. On the other hand, if the net present value you get a positive number, then that project should be accepted. The reason being the value of the firm will increase as a result of the acquisition of that particular asset or as a result of initiating that particular project. That's Borant. Now, the other thing that we are supposed to know is how to calculate the present value interest factor. Now, with the present value interest factor, because within that we're doing the time value of money, we usually take 1 plus r raised to negative n. 1 plus r raised to negative n. Now, once we have computed that particular column, whereby you'll be taking just 1 plus rate, that's the cost of capital, maybe 10% or 20%, 1 plus the rate, then you raise that particular figure, those figures, what will be in the brackets by negative n. N means the number of years. For example, if it is year 1, you'll be saying raised to negative 1. The second year, raised to by negative 2. The third year, raised to negative 3, or that way. So you'll be having as a third column, and then after that, the present value interest factors that you have in the third column, you'll be multiplying by the cash flows, and then you'll be having another column, the fourth column. You sum down all those numbers, whatever you'll be getting will be the present values, then you minus initial capital outlay, and then your answer will be the net present value. That is it. Now, having that in mind, I want us to take an illustration here, or an example, and I want us to take that question which is appearing on the screen, and you can just note down those numbers because I'll turn on to page 21. So this book is with this chapter or this area, the net present values, you still have them done by students who are taking diplomas, undergraduate students in universities. You still have ATD students for CASNEP, CPA, intermediate level, advanced financial management, and CIFA, that is CIFA, CFA, among other areas where financial decisions are required. So the concept of net present value is quite entailed, and I want us to take that particular example together. Well, my name is Mr. William, and I'm a publisher as well as an author in finance and management, accounts, economics, and other areas related with management. We've published several books, and for more details, our numbers or my number is just as it appears on the screen, the footnote of that particular page there, 0727871093. Now I want us to take that particular question as it appears there, and we discuss now practically how to go about these computations. So you can write down that particular question there, that example that we are taking. Project ABC has a cost of shillings 25,000 now. It is expected to generate the following cash flows by the end of the year. So these are projects, and see that these cash flows are futuristic figures. We expect this project to generate 9,000 shillings in the first year, that is 8,000 shillings in the second year, 7,000 shillings in the third year, 6,000 shillings in the fourth year, and 5,000 shillings in the fifth year. And then you are told that this project costs 25,000 shillings. So what we are supposed to do is that, okay, before we take the discussion, you can just check the next page. I just move to the next page, and right. So you can see the firm's cost of capital is 10%. The firm's cost of capital is 10%. You're required to compute the net present value. Compute the net present value. So basically what I have said is that what we are supposed to do is that, because these cash flows here, the cash flows that you see around here, these are futuristic figures. It's okay. In with advanced financial management, we talk of decision making under the environment of uncertainty, and also decision making under the environment of certainty. Now, realizing that these cash flows are futuristic, they are probabilistic. We are not sure whether in the second year we will receive 8,000 shillings. We are not sure whether in the third year we will receive 7,000 shillings. But we have projections. We have projections that once we initiate this particular project, or once we purchase this particular asset, we expect this asset to generate these particular cash flows in the future. So we want to see that if we invest in this particular project, will it result to lowering the value of the firm, or will it result to increasing the value of the firm? We can only arrive at that particular conclusion by calculating the net present value. That is, we get the present values of these futuristic cash flows from year 1 to year 5. We get their present values. We have said we start by opening a third column, which will contain the present value interest factors. That is, you'll be taking 1 plus r raised to n, where n is the number of years. And this n should be negative n, because you are dealing with present values. Then once you have that column, whatever you get there, you multiply by the cash flows, and then sum up those numbers downwards. You arrive at the present values. Then you deduct initial capital outlay, which means you less 25,000. What you get as the answer will be the net present value. So if the net present value is a negative, we have said the implication is that the acquisition of this particular asset will reduce the value of the firm. If it gives you a positive net present value, the implication is that the initiation of this project will increase the value of the firm, and therefore such a project should be accepted. So I believe you have that question from page 20. I want us to move to the next page, but before we go to the example, you can just see the notes as they appear there. You can just try to read those notes which you have there. If you need the book for your classes or your studies on your own time, you We can just call our numbers as they appear there, and we will supply you with the materials. So we have said there that we are dealing with the discounted cash flow techniques. We've covered the non-discounted cash flow techniques, whereby we have done the payback period as well as the accounting rate of return. So we have moved on to the net present values now, and that is what we are doing now. So I have explained what net present value is, and we have said in this case you will be calculating the present values of future cash flows. We've done the concept of compounding. Compounding involves calculating the future value given the present value. The opposite of compounding is discounting, and discounting means calculating the present value given the future value. Is the opposite of the other. So in this case here, with the net present value, we will be provided with future cash flows. With these future cash flows, we are supposed to calculate their present values as at today, and then you deduct the initial capital outlay to establish whether your net present value is a negative or a positive. Okay, with that question now, so you'll be given the number of years, then the cash flows will be provided. Yours now is to ask yourself, what is the cost of capital? That again will be provided. The cost of capital will be provided. In this case, as we have seen from the other page, it is given at 10%. You are told the firm's cost of capital is 10%. Is 10%. Now we move now to our solution. We now move to our solution. Now what will happen is that in most of the cases, the examiner will provide you with a present value interest factor table. That is sometimes it may not be the figures may appear. You may be able to get those present value interest factor numbers from the table. Other times it may not be possible. So it is advisable for you to know how to calculate those particular numbers. Now first let me show you what I'm saying. As I started by telling you that the number of years will be provided. The number of years will be provided, and the number of years have been given here. So we have year 1 up to year 5. So that's like the expected life of that particular project. Then cash flows have been given. The cash flows, we have 9,000, 8,000, 7,000, 6,000, then 5,000. Those are expected cash flows. Then, so what you do is that you get the present value interest factor, this column here. You can get it from the table, but it is advisable to know how to calculate the figures. So what you do is that you take 1 plus rate. Rate, you have said the cost of capital is 10%. So you take 1 plus 0.1. 10% is the same as 10 over 100, which is 10, or which is 0.1. So 0.1 plus 1 is 1.1. So you say 1.1 raised to negative 1, which gives you 0.91. Then you go to the second year. 1 plus 10%, or just be saying now 0.1. 1 plus 0.1 raised to negative 2, because we're in the second year. You get 0.8264. The third year, you say 1 plus 0.1 raised to negative 3. Remember, negative. It's not just n. It should be a negative because we are dealing with present values. Fourth year, 1 plus 0.1 raised to negative 4. Then 5, 1 plus 0.1 raised to negative 5. You get 0.62. 0.09. So these numbers, how we are arriving at them, we are just taking 1 plus rate, then raised to negative n. N is the number of years. Now, once you establish this column, then you multiply these present value interest factors by the cash flow. So the first, to get the present values. So the first one is 9,000 times 0.9091, you get 8182. Then 8,000 times 0.8264, you get 6611. 7,000 times 0.7513, you get 5259. And then 6,000 times 0.6830, you get 4098. 5,000 times 0.6209, 3104. So total present values, sum up those numbers together. Present values you sum up from here downwards to get 27,254. This project, you are told it will cost 25,000 shillings. So total present value, which is 27,254, you minus 25,000, you get 2,254. So this 2,000, the 25,000 is from the other side, is this point here. This point here is this point here, that you have been told that project ABC has a cost of shillings 25,000. The cost. So you are lessing the initial capital outlay. You are lessing the initial capital outlay. You are lessing the initial capital outlay of 25,000, and you get 2,254. Now 2,254 is a positive net present value. Because now we have a positive net present value, then we should accept this project. Positive net present value, we accept that project because it means by initiating that particular project, the value of the farm will increase by 2,254. Okay. Then, before I read some other notes down there in our book, I also want to illustrate how you can read these numbers from the table. The present value interest factors. If you are provided with the tables, you can read from your tables directly. Okay, just take you there. Let me take you there. Now you have seen 10%. We have seen 10%. We have seen 10%. We have seen 10%. I want to check from the table. Now check if you can be able, you can see present value of 1 received at the end of n periods. You can see here it is written 1 plus r raised to negative n. So if this table has been provided, you can see here you are given period. You are given period here. 1, 2, 3 downwards. These are the number of years. Then there are percentages on the top there. So in our case, you could have just taken 10. You can see 10% here. This 10%, you read this number here. 0.9091. 0.9091. You can see it is where we have year one. Year one at 10%, 0.9091. Year two, 0.8264. Year three, 0.773, 0.7513. Then 0.6830. Year 5, 0.6209. So that's how you go about it. That's how you read about the present value. Present, can see here, present value, interest factors, present value, interest factors. That's how you go about it. So other than taking 1 plus r raised to negative n, if these tables are provided, the third column that we have used in our calculation, you can just read those numbers from there. If it is 12%, you use these numbers. If it is 6%, use these numbers. Sometimes a percentage may not be provided. For example, you may have a table where, like in our case here, there is no 11%. So you can read 11% from here. You can see from 10%, we are going to 12%. There is no 13%. So that is where you should be able to calculate and also use the table at the same time. Okay, so I've shown you how to use the table. I've shown you how to use the table. So you should go back now to our discussion. You should go back now to our discussion. Now you are provided with that particular information. So we have discussed that. We have finished that particular question, that particular analysis. We have finished that particular analysis. The project has a positive net present value, hence it should be accepted. Acceptance rule. A project will be accepted if it has a positive net present value. Like in our case here, we have said positive net present value implies that the value of the firm will increase. A project with a negative net present value is rejected. So it means that if the net present value is negative, such a decision will reduce the value of the firm. Then a project with a zero net present value can also be accepted. Can be accepted or rejected. You have to be indifferent. Ranking. You want to rank the projects. The project with the highest net present value is ranked number 1, while a project with the lowest net present value is ranked the last. So in this case, you may have maybe more than one projects, maybe say 5, and you want to rank them based on priority. If you are to invest or if you are to initiate these projects, which one do you start with? So you start with the project with the highest net present value. So for example, you have 3 projects, one with net present value of 100, another with a net present value of negative 200, and another one with a net present value of 1000. If you are to rank them, you start number 1 with that which has the highest net present value, followed by the second highest up to the last one with the lowest net present value. So that is it for that particular example. So we move on to another illustration. We move on to a different illustration, and in that case we have an example there. We have an example whereby you are told consider. What are you told to consider? We are told to consider a 4 years project whose cost is shillings 4 million. The project has a scrap value of shillings 900,000. The cash flows for the project are given below. Now, something very important there is for you to understand what happens if by the end of the expected life of the project we dispose that particular asset. So, for example, in this question here, we are saying that a project has 4 years, and the initial cost here is 4 million. Then it means after 4 years, or by the end of the 4th year, we are able to sell this particular project or asset, and it will give us 900,000 shillings. So 900,000 shillings is an additional cash flow. Therefore, because as you have done in that previous illustration there, we will calculate the present values of these cash flows for the first year, for the second year, for the third year, for the 4th year. And again, the cash flow occurring as a result of disposal of this particular asset should also be calculated. So in the 4th year, we'll be having 2 cash flow streams. One, the 1.7, and the other, the 900,000. Then the required rate of return is 11% required. Determine the net present value of the project. So the same concept applies here. So the cash flows have been provided. The cash flows have been provided. We have our cash flows there. We have 900 now, not that. We are doing a different question. So we're here. Cash flows. We have our cash flows there. We have 9. Okay, let me check here. Okay, we have year 1, 2, 3, 4. And again, by the end of the year 4, we have salvage value. This asset can be disposed at 900,000 shillings. So the same as we have done with the previous question. So our cash flows are here. 1.2, 1,610,000, 1,480,000, 1,700,000, and the 900,000. Sometimes you can just take this 900,000, you plus the cash flows in the year 4, then you just get, because you can see the present value interest factors are the same, or you do them separately. So what you have done here is that because the required rate of return is 11%, so our column here you are taking 1 plus 11%. That means 1 plus 0.11 raised to negative n. Our negative n is a number of years. So we'll be raising by negative 1, raised by negative 2, by negative 3, by negative 4, this column here. So once you have gotten this column here, now this one you can read from the table, because our table we have seen 11% is not there. So the present value interest factors column, then you multiply by the cash flows here. You multiply by the cash flows here. So once you multiply, you get a column for present values. So 0.9009 times 1.2, you are getting 1,081,080. 0.8116 times 1610, you get 1,306,616. 1,480,000 times 0.7312, you get 1,082,176. Then you have 1,700,000 times 0.6587, you get 1,119,790. Then the salvage value, because by the end of the expected life, this asset is being disposed and you receive a scrap value or salvage value of 900,000. So this 900,000 shillings, what is its present value? Because these cash flows are occurring in the 4th year. So you still use a present value interest factor for year 4. 1 plus 11% raised to negative 4. you get this particular figure. Sum up these numbers all together. You sum up them together and you get 5,182,552. That this is the total present value. Then you minus the initial capital outlay. You minus the initial capital outlay. We are told that this project costs 4 million. So you less 4 million, you get 1,182,552. Again, this number is a positive. The net present value is a positive. Therefore, this project should be accepted, because by initiating this particular project, it will increase the value of the farm by shillings 1,182,552. So this project should be accepted. So that is all about that particular discussion concerning the net present values. That is what we are supposed to know about the net present values. Now, the most important thing for you to understand, one is how to, because the cash flows will be provided. The cash flows will be provided in the first place. If cash flows will be provided and the number of years again will be provided, the most important thing for you is to establish the third column, which comprises of present value interest factors, which you can read from the table. Alternatively, you can just calculate using your calculator. That is 1 plus r raised to negative n. Then that column you multiply by the cash flows. That is what you have in the second column. You multiply by what you have in the third column to get present values. Then after you get the present values, you sum together those present values, and what you get is the total present value downwards. Then you less the initial capital outlay. How much did it cost us to initiate this particular project? And then what you get is the net present value. So that is it for now. I think that's enough discussion. That discussion is enough. So in case you have a question, maybe you need some assistance, my numbers are down there. We are based in Vika town. So maybe you are in Vika, you need some revision classes, online classes, you need some textbooks for revision or for studies. Just contact us via our number 0727 87 1093 for CPA classes, for CFA classes, for ATD classes, and other similar classes. So again, the textbooks are available. What we are using here, this book that we are using to do the analysis for advanced, that is for decision making in the environment of uncertainty, that is the investment appraisal techniques, specifically the net present value. The book that we're using is for advanced financial management for CPA. But again, as I've mentioned earlier, this topic concerning net present values is important in both advanced financial management, also financial management, also certified investment and financial analysis, CFA, among other areas. Well, that's enough for today. So I think we should just stop. We should just stop at that. Not unless you have a question. Not unless you have a question. Not unless you have a question. So that's enough for today. We will now take the next discounted cash flow technique. Next lesson. And I want us to take the internal rate of return. The internal rate of return next time. Now, what we mean by internal rate of return is that rate which equates the net present value to zero. You know, if your net present value can be positive, negative, or zero. So the internal rate of return will be trying to establish a certain rate that if you use it, then your net present value will be a zero. How will you be getting that particular rate? So that is what we are going to pick next lesson, how to calculate the internal rate of return. So that is it for today. Remember to subscribe to our YouTube so that you get the updates as and when we have these classes, so that you may use our tutorials for your classes as you compare uh, what we do on our side with what you do wherever you are. So that's enough for today. Thank you for watching. We meet again next lesson. Thank you.